All right, we're back. We are Game 3001. That's Artificial Intelligence at George Brown, and we are in the summer 2019 semester. Week 3, Part 1, we're going to be doing a template update. I want to talk about the new stuff in the template really briefly, and then I want to talk about seeking behaviors. Again, we're going really, really slow. It's part of our first series of behaviors. Let's take a look. All right, so up on Blackboard, if you go to Blackboard, you can see that in week 3, there is SDL template version 3. You would have to download that. And if you do, you're going to see something like, let's just make session 2 here. You guys are session 2. Just going to take this template and put it into session 2. Okay, so... and at the end of this, I'm going to put up, like I always do, my files on GitHub, so you can always have a file archive you have access to. So again, I'm going to go into the template, double click, start off Visual Studio. Again, 2019 is here, but I'm still using 2017 for now, because most of you have only 2017. So I've got my template, and right now what it does is if I run it, when it builds, you should see something that looks like this. Not black screen, by the way. You should see something that actually runs. Yeah, the ship moves and then it kind of stops. So that's not really what we want, right? That's kind of a starting point. We have a seek function, and what it does for us is it moves, but it moves independently of the rotations. The rotation and the movement have nothing to do with each other. And that's not what we want. Now, the good thing about this is I put some controls, WASD, and when you move this around, it'll try to seek to the target. That's what it does right now. So it'll just try and get to the target wherever it is. You know, as an example, it'll move in that direction, it'll rotate, but it's really not moving the way we want it to. Right now, what's happening is, notice these side movements. Ship doesn't move like that, right? A ship doesn't move like that at all. It moves from its thrust. Right? That's what it does. So let's go over what I did to get us to this point. First of all, the template's really changed. I have a utility class that I've included. So take a look at the utility.h file. Under the utility.h file, I've added in a bunch of static functions that you can use anywhere in your code. I know it's not great, but what it does is it literally is just for utility functions to make you do things like clamping and distance, square distance, magnitude, all this kind of stuff that I've added in. I've also added some constants, deg to rad and rad to deg, which allows you to multiply, you multiply against this. If you have degrees and you want to make it into radians, you multiply whatever your degrees are by this value, and it becomes radians, right? So you don't have to worry about any kind of pi divided by 180 or anything like that. And same thing the other way. If you want, I have radians and I want to get degrees, as an example, then you just multiply your radians by this value and you get degrees back. Okay, so kind of very simple. Epsilon, of course, is the small value, 0.000001. And we test that to see if it's close to epsilon, it means it's almost close to 0, make it 0. Okay? And we have a bunch of other functions here. I've included lerping, random range. Some person asked this morning about, earlier in the afternoon about sanitize. What is that? It checks to see if a value is really close to 0, and then it makes it 0. That's what sanitize does. Min, max, negate, inverse, normalize, and I didn't finish dot. Sorry, I was working on it, but I didn't get quite to dot product. In fact, I can probably just delete this one for now. So this is the function that a group of functions that I have, and they're under util.h. The way to use these things is go util : and whatever the name of the function is, or the constant, and then you can use it. Okay, very, very simple. So that's the one change that I made, and that is the util.cpp is in the source folder, and you can see that all the functions, for the most part, have some kind of description. Like, for example, what clamp does. Clamps a value between 0 and 1 and returns the result. clamp 01. That's what it does, right? And so on. And there's a bunch of other stuff it does. Euclidean distance, square distance, magnitude, and so on. Okay, so lots of the little things it does that we can find here. All right, so that's the util function. I also modified the ship and the target. So let me talk about that. So first I'm going to go to solution. I'm going to go to the ship. So the ship itself, it has a seek function. It also has an angle, a max speed, and a turn speed. All right? So these are all the new things that I added in. And just to put them in there, these are all the behaviors that I added in, right? And so this is all for basically, you know, all the AI behaviors. So this is AI behaviors, steering behaviors. Let's call them steering behaviors. And we're going to put more of them. Right now we only have seek, and it doesn't really quite work well. We're going to fix that today. All right, so let's go to the seek and take a look at it. What does seek do? So I'm going to go to definition. What seek does is basically it says, look, and I have some names here I want to change. I've got targets, right? That's the target. So I get the target position. But then I have this thing called direction. There's direction, and then there's angle, right? So really, direction is the target's direction. That's what that is. So let's rename this one to target direction. So rename target direction. There we go. So that's the target direction. And then let's rename the angle, this angle thing right here, let's rename that to desired direction. So we're going to rename desired direction. There we go. And then finally, M underscore angle, let's rename this to M underscore current direction. Yes. So right click, rename. M underscore current direction. These are all different directions. These are all angles. When we see direction, it means angles, right? I've renamed them because I found in the first class, from an understanding perspective, it was better when I spoke to it. Maybe I understood it more. I don't know. But now it speaks to me. So what am I saying here? So I got the desired direction, and I want to calculate or compute the desired direction based on the arctangent, arctan2, of the x and y components of the target's direction. Okay, that's what I'm getting. Notice that in here, I'm getting a negative value for negative target direction, which may have been our cause as well. I didn't even catch that last time. But, so I'm passing this in because of the negative value, right? Because y is when it is positive on the down and negative on the up, which is kind of counterintuitive to most of us. All right, and then I have a line here that says my current direction is equal to this thing here. What is this thing called for you guys that weren't here? This thing. So I have this is equal to some kind of condition, a question mark, and then a colon at the end. What is that structure called? And by the way, this works in C++, C#, JavaScript, Swift, and a bunch of other languages. Kind of an inline if statement, but it's actually called the ternary operator, right? And what it does is it says, okay, I have a value that I want to, you know, basically I want to assign a value to M current direction, right? And it's going to take, if the desired direction minus the current direction is greater than 0, then what I'm going to do is I'm going to take the current direction and add turn speed. However, if it's less than 0, I'm going to subtract turn speed. This is a problem, my friends, and then we're going to see how it's going to affect us later on. But this is what it does right now. So this mSeek, which is the seek function, it actually happens inside the update. So in the update now I do a seek, I do a move, and a check bounce. Okay, so every frame I am checking to see where my target is, and then I change my angle, I kind of point to it, and then I move towards it with my move function. Okay, that's what I'm doing. So that's this. And then, if I take a look at my game, I've also modified my game. So if you look at the game itself, the game.cpp, inside the game.cpp, in the bottom, where I have handle events, I am now handling events for my key down for both the escape key, thank God, right? WASD for moving my target around the screen. All right, so the way it works is when I press the W button, it's going to get the current velocity of X and leave it where it is, and then subtract 1 from the Y. And then, of course, multiplying that by the current speed, whatever the current speed of the object is. So that's how it moves around. And then on the same side, on the bottom, when I key up, when I lift my finger off the keys, it's going to stop the motion in that direction that I was going. So to try it again, I can move my target, as you'll see in a second. So I can move my target around, right? And then it'll seek towards my target. It'll move towards my target. Now, it's not terrible, but it's not good either. Now, the reason why it's not good is because the ship doesn't move like this, right? The ship doesn't move side to side. The ship has some kind of thrust that comes out of the back, right? And what we want is to go with ship motion. So wherever the ship is looking, I want, the ship to move. And then what happens is it should move in an arc. Okay? That's what the ship should do. So instead of the ship moving like left and right, for example, look, it's just moving left and right, right? That's not cool. Even though it changed direction and stuff like that, who cares? Or even down, it just moves down, right? Sure, it'll put itself on top of my object. Okay, nice. But it really doesn't do it in an organic way. This isn't really seeking behavior. I mean, it is, but it's really kinematic. There's no dynamic part to it at all, right? This is like the basic, easiest way of doing it, right? What we want today, and this is your challenge, is I want you to make it so that the ship can only move forward. It can't move left to right. It can only change direction. So it changes direction based on the location of the target, but it always moves forward, right? Based on its direction. That's what I want to do, okay? So that's the input. So the input right now, it kind of moves the target around, and it allows us to, retarget kind of check to see if the seeking behavior works. And this very simple seeking behavior, it does, because it basically moves wherever it is. Doesn't matter where I move it, even if it's off screen, it'll try and move off screen too, or back, right? That's pretty good. But what we want to do is we want this smooth arc to happen, right? So what I want to do is this ship should move in a direction where the target is, but I want it to move like as if it had thrust. So it's moving according to its facing. Make sense? So how do we do that? So a couple of things to note, right? And where I want you guys to start off. And I'm going to stop recording. This is the part of the challenge. So the challenge is a little bit longer this time around. Earlier, when I made the challenge, it was kind of at the end of the session. This time it's going to be much earlier. What I want you to do is I want you to, in the next 10 minutes, play with the templates. Modify the values. See what you can get, right? Understand what's happening. Because what I want you to do is how this thing is working right now is incorrect, right? What's supposed to happen is the direction the ship is pointing, which is this direction, right? What is that angle? You can actually look for it. So if I want to know what the angle is of my ship, the actual current direction, what is that right now? Let's take a look. So the way to do this And I can do that anywhere, but let's just do it inside of our seek function because it's being called every frame. And if I want to know my current direction, what my current direction is, right? And I can do it in different places. My current direction right now is being modified down here based on my desired direction. Okay, so if I wanted to kind of do a C out, I can do std : C out, and then you can say something like current direction. Oh, what is it? And we can kind of put out the m_ current direction. We can concatenate that with the end line symbol. That's what that is. And then we should be able to get in our console some indicator of our current direction. Notice that it changes. And what's happening is it says -90. Let's do that again. All right, so it looks like -90, and then it stops. Current direction. Does that make sense? Does -90 make sense? Guys, the answer for me is, I think not. And if I move this around, you can see now that it's -180. Here, it's negative, and then it becomes a positive number, like a 90. Here, it becomes 0, and then it becomes negative again. So something's messed up with our current direction, right? Why is this happening? Well, because I'm making it turn to the right, now it's turning to the left. And it's jigging out like that because of what I'm doing. But you can see that these directions, 90, and if I can make it go -90, -90 are weird, right? So that's the first challenge. What should be the direction of our ship? Does 90 at this angle make a difference? Is it reasonable? And I'm here to tell you that it does not make any sense, right? Here's the other thing. So that's my direction. The other thing I can also pull for is, instead of my current direction, what is the desired direction, right? So let's take desired direction and put it in here and put this in here. There's my desired direction. All right, so what is that? So now you can see that my desired direction is -90. How about now? My desired direction is 180. What? How about now? My desired direction is 90 and some. How about now? My desired direction is 0. Doesn't make sense. And that's the thing you got to figure out, because if it doesn't make sense, guys, right, no matter what you do, once you start moving your ship around, it's not going to work. It's not going to work at all, right? That's number one. Second thing is the bugs in the code. Second problem. The way I'm going to move my ship around is I'm going to calculate the next pixel based on my velocity, right, and my angle. So if I'm angling somewhere and I want to go in a particular angle of attack, right, I'm going to take the velocity multiplied by the x component, right, so which is the cosine of the angle. So my velocity times the cosine of the angle. Why cosine? Because cosine is related to x, and the angle, depending on my elevation or my angle of attack, there's two components to every angle, x and y. I'm taking the x component and I'm deriving the length of my x based on how much velocity I have. It's not going to be 100%. If it's at a 45-degree angle, there's going to be equal amounts of x and equal amounts of y. Okay? If it's steeper, like let's say something like, I don't know, like a 60-degree angle, there's going to be more energy in the y-axis than in the x-axis. Less forward motion, more upward motion, right? So therefore, when I use sine and cosine to get the components of my angle, I'm going to take the component out. So in other words, I'm saying, okay, here's my velocity. I'm multiplying it by the cos of my angle to get how much energy is left on the x-axis, how much energy is on the y-axis, and then I'm going to compute my next x and y pixel for the next position of my ship. That's based on what direction it's pointing in. However, the direction it's pointing in is cuckoo, right? It's pointing in some wacky negative 90, 90. It doesn't make sense. So when I plug in my values for X and Y, it's going to go in the wrong direction. Okay, so I got to fix this problem. Also, right now, the way we work, if you notice the code, it says, well, I have this line here that says, my current direction is my desired direction minus my current direction. If that's greater than 1, then what I want to do is I want to add, so if it's positive, it's a positive rotation, I'm going to add turn speed to my current direction. So I'm going to turn towards the direction of where my object is. This seems to work in the code, and only through magic. It shouldn't actually work the way it works, right? And the reason why it works is because all the angles are similar. They're all negative and they're off, but they're off together. Like the coordinate frame has been offset, but it doesn't matter because everything is offset. The problem with that approach is that our understanding becomes weird, right? We're like, wait a minute. Up should be 90, to the right should be 0, and so on. And if you look at the compass rose, if it's to the right is east, up is north, left is west, and down is south, right? So 0 would be to the east, up, 90 degrees would be up, 180 would be left, and so on. It's not doing that right now. We have a completely different angle, a basis, if you will, for our coordinate space. Now, we could normalize it. We could adjust it so that it's to this new coordinate space, which I recommend we do. That's what I want to do. So again, your challenge, and here's the challenge. I'm going to leave you with this. I'm going to let you play with this for 10 minutes. I'm going to stop recording. I'm going to go around, check you guys out. Is this: the ship should only move according to its engines, wherever the engines are pointing. Okay? The engines for the ship, by default, are behind it, right here, right? So it should only move in this direction. That means if I move my target to this, it shouldn't be able to somehow, move to the right in exactly at right angles. It should do an arc, right? Because it's following the engines as it's turning, right? And the ship should arc until it finds its location, so it finds the target. That's seeking behavior, right? And that's directed according to what you're looking at. Whatever you're looking at is where you're moving, right? Now, this could work in some kind of weird space game where you had side thrusters or something. We don't have side thrusters. We only have back thrusters. I want you to think of that. There should be no way you can move the ship backwards. The only way you can move is the ship forwards and turn it, okay? So we need to make some changes to our code in order for us to accomplish this. Okay, so I'm going to stop recording. I want you to try it. I want you to try and make it so that wherever the ship is moving, right, wherever it's looking, it's moving. If it looks to the left, it moves to the left. If it looks to the right, it moves to the right, right? And it cannot move left and right if it's not looking left and right, okay? It can only move where it's looking. That's what I want it to be. A couple things of note and some hints that I gave the other class. A couple things you could do is if you wanted to test out the moving functions of the ship, you could go into the game.cpp and modify the movement code so it doesn't affect the target at all. The target stays the same where it is, but rather it moves the ship. So if you can make the ship move by itself with your keys in the right way, then you have the code that you need for the seeking behavior to work in the same way, right? Right now, if I was to use this code and I have to modify this so that the ship moves, I'm going to do this in a second, rather than the target, let's do that. So I'm going to just change these names from M target to M_P ship. M_P ship. Let's just move this so I'm moving the ship now, not the target. I'm just going to change all this and these and these. And what we're going to do is we're going to turn off seeking for a second, so I can show you what the problem is. Okay, so we've changed all those. So now it says M ship instead of M target. And I'm just going to turn off seeking on the ship. So seeking is being called inside the update function, right? Which is right here. I'm just going to turn it off. I'm just going to kind of comment it out. So no more seeking. How does my ship move? How do you think my ship is going to move now based on my current code, the way it's going to move? How do you think it's going to move? Will it turn when I'm moving left and right? Do I have any turn code right now? The answer is no, right? So if you actually see my ship, and this is hints for you guys, if you actually see my ship now, it just literally does this, right? That's unrealistic. Front is okay, back should be impossible, left should be impossible, and right should be impossible, because ships don't move that way, unless you have side thrusters. And I want you to assume that our ship doesn't. There's no side thrusters. Okay? If you want to, and some other simulation or whatever you can, but for our simulation, I want you to assume that our ship has no side thrusters. Okay? So, what do I need to do in my keys to rotate left and rotate right, but not move right and move left? And when I move forward, depending on wherever my rotation is, I want to move in that direction. It's kind of a known problem. It's a solved problem. It's not something that's not solved. And again, hint, take a look at your current velocity multiplied by cos theta, theta being the angle of attack, whatever the angle that the ship is, and for the x-axis, and sine theta, so velocity sine theta for the y-axis. And that's how you can get the next pixel, right, for the ship, depending on where it's looking. But we have problems. Where the ship is looking right now is incorrect, right? And a good example of that is, if I go down to, now seek isn't being called, but let's do it inside of our update function. So in my update function, I'm just going to call a cout. This is bad, but okay. We'll say that current direction, right? Here's my current direction. And it should be m underscore current direction is what I called it. And we're going to use the standard end line symbol. When I press play, then we should see the current direction is 0. And now I go back to you. If the current direction is 0, is this correct? Should this be 0? And I'm going to tell you, if in our coordinate frame, it should not. This should not be 0. This should be 90, right? Because it goes 0 to the right, typically 90 up, 180 to the left, and so on. So if that's true, there's two ways to do it. I could adjust the coordinate frame by subtracting or adding 90 to it. I could add 90 degrees to the current position or the current direction, right? Or, and this is what I did earlier, is currently my ship model, my texture is actually pointing up. And by default, my texture should be pointing to the side, right? So you could, this is what I did earlier, I just changed my texture so it looks to the right, and now 0 is correct, because 0 is pointing to the right? So let's do that. I'm going to go here and go into my assets, and my texture should be pointing to the right anyway. So I'm just going to go into my favorite program here, Fireworks, and I'm going to do a rotation. So I want to, do a rotation here. Transform. I want to rotate 90 degrees clockwise. And what I also want to do is I want to go modify canvas and then fit canvas so that it fits snugly in the canvas and save. And now, you can do that with any program, by the way. And now my ship is going to be facing to the right. Now, why do I want that? And you're going to say, wait, that's cheating, right? Yes and no. Yes, I've solved my problem of the direction, because 0 should be to the right. That's the coordinate frame I want, right? That's what I want to do. And I could have, implemented an offset system and so on for the current asset. But it's better to do whatever you have to do in the assets without calculations. That's the answer for sure. The more calculations and transformations you do inside the code, the choppier things get. Okay? So, going back to this, if I run it now, you can see that my ship will start, didn't put a breakpoint for sure in there. What happens? Right. My ship is to the right now. Right? You can see my ship is to the right, right? And it makes sense that my ship would be to the right because To the right is 0. So now I'm aligned properly. Okay. And that's what I recommend you start with. So I'm going to stop recording here. And when we come back, I'm going to come around and check you. If you need the assets, so it's to the right. I mean, literally all you have to do is rotate it to the right. Any program will do, as long as it's compatible with PNGs, right? If you want to do what I'm doing, or you can use an offset. So add 90. Okay, so I'll stop recording here and I'll come around.